Answers to assignment questions. Question 101. This question is quite the same as question 100. But in this case, we have a cold container together with cold water. The temperature is going to increase from 22 degrees Celsius to 40 degrees Celsius. We have to find the energy absorbed by them. First, we find the energy absorbed by water using the equation Q equals mc delta T, where delta T is the change in temperature. Next, we use the equation Q equals C delta T, where C is the capital letter C. This is the heat capacity of the metal container, so that we may find the energy absorbed by the container. So together, we can find the total energy absorbed by them in order to increase the temperature to 40 degrees Celsius. And so the time of heating is given by Q divided by the power of the heater. Question 102. So which one may keeps you warmer? Is it the metal piece, 5 kg of copper, or water, 2 kg of water at a lower temperature? The answer is water. Why? We have to find out the energy released by them. For example, if the final temperature is 37 degrees Celsius, which is the body temperature, then the energy released by water would be this value, while the energy released by copper would be this value. And then you can see their specific heat capacity are very different. That of water is 10 times larger than that of copper. So even though there is only 2 kg of water multiplied with the temperature change, you can see that water can release much larger amount of energy than copper. In other words, water can keep you warmer. Question 103. So in this question, there is an electric heater of 250 watts, while there is also a power loss of 40 watts. Simply speaking, the power that is heating the water is only 210 watts. So, with this 210 watts, multiplied with the time taken in seconds, this is the energy supply to the water, Q. And this Q equals mc delta T, so that you may find the mass m, 0.75 kg. Question 104. This is quite a similar question, but this time you are asked to find the time taken. So, this is the power of the heater, but then there is also a power loss. So, we have the energy given by 250 multiplied with the time taken. And this is going to be absorbed by water, so that its temperature increases from 20 degrees to 60 degrees. In this way, you may find the time taken. Question 105. Well, in the last question, the actual time taken is even longer. Why? Let's take a look at the last question. Now in this question, it says that the power loss is 50 watts for that water at 30 degrees Celsius. However, the average temperature of water should be about 40 degrees Celsius. And this is now 30 degrees Celsius, 50 watts. So at 40 degrees Celsius, the power loss should be larger than this, 50 watts. Right? So our answer would be, since the rate of heat loss, which is the power loss, should be higher than 50 watts, because the average temperature is 40 degrees Celsius, but not 30 degrees Celsius. So the power loss should be higher. Question 106. You are asked to find the specific heat capacity of the liquid from the graph. So you must know how to read the graph. Now there are two equations. One is Q equals power multiplied with time. So the time taken from the horizontal axis, and then Q equals mc delta T. The energy provided by PT is used to increase the temperature of the liquid. For example, when the time increases, the temperature increases from 22 degrees to 26, or even finally to 26.8 degrees Celsius. Now, if you take this point, the end of the line, then you can see it takes 47.5 seconds to increase its temperature from 22 to 26.8 degrees Celsius. So that's the first equation. On the other hand, you may make it easier. You may look at this point instead, so that the temperature increases from 22 to 26, and then it takes 40 seconds only. Alright, so this is then the next equation. You may write any one of these two. Any one of them is correct, so that you may find the answer. Question 109. Do you notice that in this setup, there's no stirrer? So, would it affect the experimental result? The answer is no, it would not affect the result. The result is still good, because metals, such as aluminium, is a good conductor of heat, so that it conducts heat very well, so that each part of the metal will have the same temperature. In other words, the temperature is uniform. So the thermometer can measure the average temperature of the metal. Easy. So what about if we replace the aluminium with glass? Question 110. Can we repeat the experiment using glass to find the specific heat capacity of glass? The answer is no, we cannot, because glass is not a good conductor of heat. It does not conduct heat very well. In other words, the temperature inside the piece of glass is not the same everywhere. It would not be uniform. So we cannot measure the temperature of the glass accurately. Question 111. In the experiment, we have to add a few drops of oil into the holes for thermometer and heater. Why? Because the oil can improve the thermal contact, that is the heat conduction between the metal block and the heater, and also between the metal block and the thermometer. Otherwise, there would be air between them, so that the heat conduction between the metal block and the heater and the thermometer would not be very well. In other words, the heat from the heater cannot conduct to the metal block, and the heat of the metal block cannot conduct to the thermometer. There will be larger heat loss, and the experiment would not be accurate. Question 112. Even though we have added oil to the holes, the experiment is not very accurate. The experimental value is always larger than the standard value. Why? Because there is heat loss to the surroundings. Let's find out how we may reduce heat loss to the surroundings in this experiment. Question 113. How we may improve the setup? We may wrap the metal block with cotton wool. We may cover it using cotton wool. Or we may put a piece of foam or wood, which are heat insulators. Put any one of them under the metal block to reduce heat loss. Question 114. In this question, 7,000 joules of energy is supplied to 3 kilograms metal block, and the temperature of it increases by 5 degrees Celsius. Let's find out the specific heat capacity. Using the formula Q equals mc delta T, then you may find its specific heat capacity. Note that the specific heat capacity of metal is usually small, just a few hundreds. And also note that you have to give a correct unit. J per kilogram per degree Celsius. Next, you have to find the heat capacity, which is the capital letter C. So this would be 1,400 Joule per degree Celsius.